Okay, part two, we're going to be talking about reflections. When you're reflecting, you're going to be reflecting over some line, okay? When the lines are horizontal and vertical, you move in the same direction. So if you're forward to the left, you go forward to the right. Forward up, you go forward down. If the line is diagonal, like it is in this example, you change direction when you hit the line. So if you start counting from the left, then you would go down. If you start counting down, then you will go to the left. So it's kind of the opposite. And I think it'll make more sense in a second when I show you an example. But is a reflection an isometry? Again, yes it is, because it's the same size, which is the important thing, in the same shape. Okay. First example, the point 3, 4 is reflected across a line y equals 1. What is the coordinates of the reflection? Okay. The hint says graph the line first. That's not a hint, that's just what you gotta do. Okay, so we got, where would y equals 1 be? So okay, you're gonna go start at the origin, go up 1. Now this is a little counterintuitive, but y equals lines are horizontal like the x-axis. Okay, x equals line will be vertical like the y-axis. So that's just a little trick. It's a little counterintuitive. So if we were to plot this point, 3, 4, that would be up here. So now we just have to count how far it is away from the line and go the same distance in the opposite direction. So point P is 2 or 3 above the line y equals 1, so we got to go 3 down to plot the new point. So it'll be right there. So P prime would actually be at 3, -2. Notice that when we're reflecting over a horizontal line, the x doesn't change. It was 3 in the original, it's 3 in the copy. Okay? That's because you're reflecting over a line that's horizontal. Now the opposite is going to be true if you reflect over a vertical line. So let's see. We got x. So the next part of the example, we got x equals -1. So that's going to be here. So we are 1, 2, 3, 4 away. So we got to go 4 another direction. 1, 2, 3, 4. That's going to be P prime. And like I said before, since we're reflecting over a vertical line, this time you notice the y coordinates stay the same, and the x is now -5. Also, it might be helpful to think of this like a number line, right? If x equals -1, right? The two numbers we had for the blue, the original point was 3, and then for the green, the copy is 5, -5. So if you think of it like a number line, you know you're right because they're both 4 away. So that's another way you can think of it. Okay. Now, writing a rule to describe a transformation that's a reflection, okay, is a little bit tricky, but all you really have to do is identify one of the points that is both the pre-image and the image, or the original and the copy, and split the difference. So on this one, if we look at f and f prime, right, your eyes are clearly drawn to this line right here, okay, that is in the middle. F is 1 up from that, f prime is 1 down from that. Okay? So your rule would just be reflect across And then whatever the equation of that line is, this one is horizontal, so you know it's going to be y equals, and it's up 2, so it's going to be reflected across y equals 2. Now, the tricky reflection is when you're reflecting over a line that's diagonal. Okay, so y equals x, everyone should know what that looks like. It's a parent function for linear functions. It means for every value of x, it's the same value of y, 1, 1, 2, 2, 3, 3, 4, 4. Okay, so like I said earlier in the video, the challenge for this is you switch directions. So if we start with maybe s, okay, s is at -2, 1. Okay. If I count over to the line, I can either count to the right or I can count down. Okay, so if I count to the right, we're 1, 2, 3 away. So instead of continuing in the same direction, like we did with the horizontal and vertical lines, we actually have to switch direction. So we actually have to go down to figure out where the new s is going to be. So s prime is actually going to be right here. Okay. Now, I'm sure you'll notice this trick. If we plot, or if we ask what the coordinates of s prime are, we can see that it's 1, -2. Okay. So if you notice that for a y equals x line, the rule is whatever your x and y are, they just switch. So if you remember that, you don't even have to plot them. So like w is at -2, 3. So we know that w prime is going to be at 3, -2. Because we just switched the numbers. So 3, -2 would be here. Okay, so that's really the trick with the y equals x line. Let me make sure I got everything right. It looks kind of funny. -2, 1, switch them. 1, -2, yep. -2, 1, 2, 3, 3, 1, 2, 3, -2, yep. All right, so if you remember the rule, you don't have to worry about counting. But just remember, if you want to count for a diagonal line, either y equals x or y equals -x, you have to change direction. So if you're going left and right, when you hit the line, you got to go up and down. Okay, that's it for reflection. Next video will be dilation.